Hello, Mr. Eric, Mr. Ryan. How are you today?
Babies, we're gonna do. Okay.
Yeah. So given a list of numbers, integer, non-negative integer means that the smallest number is 0, non-negative, like 5, 3, 0, 9.
That's 0, not O. O's your number.
Okay, so you're given a list of numbers, non-negative. What's non-negative?
5.
Non-negative. What's non-negative?
Oh, it means not like below 0.
Not below 0, so it's bigger or equal to 0. Okay?
Yeah.
Okay, so if I tell you that there are k numbers in here, right? The k numbers which are greater or equal than k. Okay, so k numbers here which are greater or equal than k.
They're 4. Yeah. They're 4.
Sorry, what's 4?
They're 4k.
No. There are 4 numbers, but I'm telling you k is a number. There are k numbers here which are bigger than k. So find out k. So you need to tell me what is k. Find out k. And if k doesn't exist, then you need to tell me k equals minus 1. Okay? So for example, how many k will be here? 0, 1, 2, 3, right?
So
4.
how many much are bigger or equal?
Yeah, look Eric. What's possibility of k?
K. No. This nums.
Yeah. It could be 0, 1, 2, 3, 4. Yeah? Yeah? Okay, so 0 numbers here bigger or equal than 0? Yes or no?
No.
Why is that? Because there's 0.
There's none below.
No. When k is 0, what does it mean? Can you find any number here which are bigger or equal than 0?
There are 4.
Yes.
The output is 3.
Okay.
So is 0
One-
and 4 are not the same?
Not the same. Yes. And 1, how about k equal to 1? One number is bigger than 1? No, because they look. Yeah?
There's no 1.
Okay. No. Look, 3, 5, 9 are bigger than 1. Right?
Yeah.
So, you see? It's not the same.
Yeah.
Look, 2, 3, 5, 9, 2. Again, not the same. 3,
3, 5, 9, yes, the same.
3, 5, 9, and then 3 is the same. So, yes. Okay? So, got it. So, find out the k. Any ideas? Any ideas?
Oh, we just do the thing what you did.
Whoa, yeah, exactly. That's very clever. Yes. What's that called? What's that called? Hey, what's that called?
I don't know, the thing you did. You're negative.
Blue force thing. Come on, that's the most straightforward, intuitive way. Okay, so we blue force. So we blue force all the k, and we check, we count how many numbers here are bigger than k, right? Yeah. Okay.
Stop.
Please. Okay. Okay, can I write it? Yeah. Can I write it?
Maybe you
So
can.
look, Eric.
Maybe you can.
So first of all, we need to come up with a function to count how many numbers that are bigger or equal than k, right?
Yeah.
How can we do this, Eric? If the numbers here define, let's count. Let's make it count. Count the bigger or equal, right? Equal than k, right? And if I have numbers here, yeah, numbers here. Can I have your attention, please? Can I have your attention? Can I have one of these, please? Eric,
I'm
Ryan,
taking this one.
Eric,
And I'm taking this.
how can we implement this function? This is supposed to be very easy, right? Eric?
Yeah.
Count bigger or equal than k. How can we count it? Alright?
Okay, so we start from 0.
No. I'm saying now it's the simple version, which is I already tell you. I want to count the numbers in the numbers in this array. How many numbers are bigger or equal than k? Can we just do it with the for loop? Yeah? Eric, does it make sense, Eric? Can you write the for loop?
No.
Eric, look. Answer equals 0. Okay? And then certainly here you need to return answer, right? Yeah? Alright?
Yeah.
And so I want to go through the numbers in nums. How can I do it? Alright? Everyone, do you know how can I go through the number?
4.
Yeah, for what? For what?
Something.
For something. Okay, for something. Yeah, something. Yeah, you can. It's a variable for something. In
Yay!
what? In what? In what?
In K? No.
Okay. And then what? What?
Column.
Okay. And then how we want to count how many numbers are bigger or equal than k. So what's next here? What's next here?
If K.
If what?
No, if nums.
If what?
If something.
If something. What?
If something bigger.
Equal than k. Right?
Yeah.
Column.
Column.
And what should I do here? Then what?
Then we show.
What should we do with the
Answer.
answer what? Answer what?
Equals
We want to count, yeah? Answer what?
add equal 1.
Yeah, well done. That's not difficult, right? You got it, right?
Maybe. It's
What's the time complexity of this part? What's the time
Big
complexity
brain.
of this part? Oh, if there are n numbers here.
He can fill in this part.
Eric, what's the time complexity? What's the time complexity?
And
Oh, n, yeah. Can I have your attention? Otherwise you write it, okay? Nums.
you have to get your.
Do you want to write it or not? Can I have it?
Okay. Psych.
O-N, yeah? O-N. Okay, so we have this function, okay? Remember, we have this function. Can we do it better? Let's improve
Maybe
it.
we can.
Let's improve it.
Maybe we can't.
So every time, Eric, every time we need to use this function. This function will be used a lot, right? Because if we do the brute forcing, we just do this. For what? K in range. Alright, look. Range what? Range what? To what? To length. Yeah, how many numbers? Yeah? Nums.
That looks
Plus
like
1.
mums.
Yeah, nums. Eric, look,
Or
listen.
limbs.
Focus, Eric. Right? We want to brute forcing the K, right? Eric?
Yeah.
And then look what? If, let's call this just F, okay? You know what it means. If Fk equal what?
Equal K. The other one, I don't know how to explain.
Yeah, it's K, yeah. We want to brute force K. If Fk means the number of elements which are bigger or equal than K. If Fk equals K, return
Return
K, come on. And otherwise return -1, yeah?
Return -1.
What's the time complexity here?
B.
What's the time complexity
Look
here?
it.
What's the time? Here is what? Here is what? On, yeah? Here is on.
Yeah.
And here is what? On. So what's the complexity?
N squared. That's more worse.
On squared. So it's very bad, right? Yeah? So look,
You shouldn't tell us that one.
as a comparison, look, Eric, do you understand, yeah? Yeah, brute forcing, yeah? That's what I did at the beginning, right? Yeah?
Yeah.
So
I
if we can improve this function, then we can improve the overall complexity, right? So there are two ways to speed up, right? And right? Either we improve this function, or we improve this, right? Right? Because this algorithm consists of two parts. You want to iterate over k elements, k possibilities, the n, yeah, k from 0 to the numbers, yeah. And then for each one you want to try. But this function, it takes on, right? Alright? Yes? Does it make sense, Jerry? Got it?
K.
Does it make sense?
K.
What's okay?
K. K.
If you say okay, I'm going to ask you. What? Okay, can you explain to me what's this part?
Let me do the handle.
Yeah?
Me got the pen.
What's this bit?
Okay, so that is the thingy that how many number are bigger. Yeah.
Uh-huh.
And then this is the
Yeah.
the number that is compared to I didn't have to explain that. That's
If it's the same, yeah. If there are k numbers that if there are k numbers which are bigger than k, then we return k. If we can't find any k, how many k possibility? There will be n plus 1 possibility from 0 to n, right? And otherwise we return minus 1. Got it?
like my bed now.
Please. Okay. Okay, so we can improve two bits. First of all, we can improve this f function, or we can improve how we search this k value. Am I right?
Yeah.
Okay. So first of all, let's improve this f function. Okay. How can we improve it?
Pen.
Eric, how can we improve this f function? Eric.
No.
Alright, look, if this is the list of numbers, wait, listening, can I have your attention, please? This is lesson,
I'm
not
not
playing. Okay.
Ryan's laughing.
Ryan,
Is
listen.
me? Is that right? No, it wasn't.
Okay, let's see.
It was you. No, it was you.
If this
It was
number
definitely
is
you.
3, 5,
You.
do you want me to do it again?
No.
Okay, 3, 5, 4, 2, 4, 1. Okay? So if I want you to, this is the list of numbers. If I want you to tell me how many numbers are bigger or equal than 2. So how do we do it? Yeah? But if imagine this is a very big number, you have to check from the beginning to the end, right? Yeah? Alright? This is ON, right? Can we do better? Or can we make it better?
Sort it.
We're done.
Yeah,
Sorting.
I got it, baby.
Yeah, okay, but look, wait.
Yeah,
Sorting is what?
I can look at it.
Oh, and okay. But you only need to do it once, right? You only need to do it once. And after sorting, you'll be what? You'll be what, Eric?
It'll be much easier.
You'll be what? 1, 2, 3, 4, 5, right? Right, am I right?
Yeah.
Then if I want you to find out how many numbers are bigger than equal than 2, so how would you do it over this sorted array?
Okay.
How would you do it?
If you're looking at you split in half. And
yeah.
then it's in this half, and then you split in half again. You found it here, babies. And then
Wow.
you do the after it. Easy peasy.
Well done. Wow, that's very advanced. Okay, I was going to explain to that later, but you got it straight. First of all, if it's sorted, it's better than I can just do this. Yeah, I can just search from the beginning. Yeah, when I found these two, or I can search here from the opposite. When I found a number which is bigger. Okay, let's do this side. Which is bigger than 2, right? Yeah, and I don't need to continue, right? Got it? Why is that? Because all the rest number will be bigger than 2, am I right? So I can exit the check earlier, yeah? But the time complexity for this is still ON. Why is that?
Why? Oh, because it might be here.
Yeah, it might be the end, right? You still need to go through the end, right? Wow, well done, okay. But the other thing is we can binary search for this one. So as you say, I want to find a 2, yeah? And I can do this number with finding that number in O log n, right? Yeah? That's much faster, right? In Python, we can use this function. So look, let me write this there. If an array is 1, 2, 3, 4, 5, 6, okay, it's sorted. And I want to find how many numbers. Let's say I want to find the 3. Okay, I want to find the 3. So I can use this function bisect. Bisect. Bisect, what's it? Or the binary in, I don't know, bisect left.
Bisect.
This is the package name. Import.
Bisect don't make no sense.
Okay, so
I like it.
So Eric, from, you can do this, from bisect. This is the package name.
Bisect.
Yeah? Import 2 functions.
Import.
Bisect. Underscore. Left. Bisect. Right.
Underscore.
It's not bisect, it's bisect.
Okay.
Yeah,
okay.
that's exactly what he said.
So what does it mean?
Is it bisect?
What does it mean?
No,
It takes 2 parameters, Eric. The numbers, the list of nums. The first parameter is this. Yeah. Actually, it can take up to 4 parameters. The third and fourth parameter will be the range, lower to higher, but let's forget about it now. The first parameter is nums. It's the array already sorted. And you want to find the x, let's say target. Yeah, target. So what's the difference, I tell you? If I want to find a 3, where to find a 3? Alright? If I want to find a 3 in this sorted array, it takes O log n, right? Yeah, n is the number of elements in this here, right? Yes? 3 is the position left. Is that if I want to put the number, which is, so I find this number here, right?
Yeah.
And then you tell me the position to put it is here. So that's 0, 1, 2, right?
So you start from left.
So yeah. So and by set right, you will return what? It will be here.
Yeah, there.
Yeah, exactly. So what? How does that help? If this number is not in the target, right? If I want to find 3.5, 3.5.
Testing 4.
Eric, look. If it's 3.5, it's not in the sorted array. So can you tell me? Can you point me to where it is?
Interesting.
Interesting. It will be what? Where you will be pointed? 3.5. Where is again? Let's say
Wait,
when
this
is
is left.
Yeah. So you can think of it that way. You find the position to put 3.5 in, and it's still sorted. Where is going to put? Where are you going to put 3.5?
3.5 has to be here.
Yeah, where down? So here you can't find this, but you can still find a position for 3.5 to in. So that will be 0, 1, 2. Right? 2. Yeah? 0, 1, 2. Actually, it will be return 3 here. Yeah, because that 3 index is going to play. You want to put a 3.5 in index 3. And if it's bisect right, what does it mean? It will be here, right? Yeah? Alright? Yeah? 3.5, you'll be put it after, right? Got it? So how does that help? If we found this number bisect, that's k, Eric. K, that's okay. Look, if bisect numbers k, right? Yeah? Alright. What does it mean? If k is bisect number k, if I put it here, so what does it mean? How many numbers that are bigger or less equal than k? Can you tell me?
Bigger.
If this is number is x, yeah? If this is number is x, so how many numbers are bigger or less equal than k?
K.
Is this bit or this bit?
The same.
No. In this case, it's the same. I'm talking about if x equals bisect left k, it means that I can put a k in the sorted array at the x position.
Yeah.
So, can you tell me there are x numbers bigger than k? X number here bigger than k, or there are n minus x number bigger than k? Which one? Pick one. If this is sorted.
Wait.
Just pick one. Come on, you got a 50% choice.
What's
minutes.
What's this?
Yeah. X. Look, x is the number of positions to put the k in this sorted array.
What's that?
No. I mean, there are x numbers bigger than equal than k, or there are n plus n minus x number bigger or equals than k.
And the numbers.
The numbers of elements in this array. So I'm actually asking you, is this bit bigger than equal than k, or is this bit bigger or equal than k? If I find a position to put the k in, if it says sorted, come on, it's very obvious. Which bit?
That bit.
That's the right. What? Come on.
Wait.
Right, yeah, of course, right, it's bigger. I put a 3.5 here, so how many numbers are bigger than equal than k? Of course, here, 4, 5, 6 is bigger than k, come on. Yeah, it's quite easier, easily stupid, yeah? Okay, so remember, this f function, we can improve the time complexity to what? with this function, we can improve the time complexity to what?
K.
O what?
In
Log.
20
And
minutes.
O log n, yeah, log n. But we need to,
Actually, log K.
yeah, log n. But remember, we need to solve this array only once, yeah. Which it will take. O.
Log N.
We're done. That's for sorting. Okay. Now, good. So, what's the second part we can optimize? What's the second part we can optimize? Remember, we iterate brute force for the k from 0 to n, right? Yes. But we can binary search it. Am I right? Yes. Yeah. Am I right? We can binary search it. Am I right?
Yeah.
So, actually.
I know it's 21 minutes.
Actually, can you pay attention? Actually, the k, the upper bound of k is what? It's not the number of elements. I made a mistake earlier. Right? Look, 5,
Why didn't you
3,
say so?
0, 9. What's the maximum k you are talking about here?
Nine.
It's not 4. It's 9, right?
Yeah, I said 9.
Yeah, okay. Right? Because the k, the maximum is 9. It's the maximum of numbers, right? Alright? It's not actually the length of numbers, right? This is the upper bound, right? Yeah? So the diagram before, the brute force thing is what? O max k, O max n times n, right? The beginning, it's not O n squared, right? It's O max n times n. Could be bigger than O n squared, am I right? Yeah? So now we can binary search this bit instead of linear search. That's what I'm saying. The lowest will be n, the biggest is max n. And then we can binary search this one. And then this will be O log max n, right? Log max n. Right? And then times, what's the f function?
Times 1.
What's that? Yeah, it could be great if we can reduce it to O1, but it's not possible. What?
Well, maybe
O-
it is.
O log what? The number of elements, right? O log n. So the overtime complexity will be this one. O log max n times O log n, right?
Then
So
we
how
put
can
the column.
Yeah, how can we binary search this? Okay, I'll show you. Look,
It's
Eric.
so long.
Almost finished, yeah? Almost finished. Look, Eric, look.
It's been like 20.
Count.
It's 23 minutes.
5k.
22 and 59 seconds.
Find k,
23.
okay? Eric, find k. The left equals 0, okay? The smallest k will be 0, right? The maximum k will be what? Tell me.
The K is nums.
Max of nums. I just tell you max of nums, right?
Max nums.
Okay. Now, how do you write the binary search? While
Sort.
left smaller or equals than right, okay? Yeah? Here, the nums is already sorted, okay? Right? Already sorted. Listen. Y left smaller than R. What's the middle? How do we get the middle? What's the middle part?
Middle
This-
equal left plus right.
this-
Divided by 2.
yeah, middle here.
Middle equal left plus right.
Divided by 2.
Divided by 2. You need to divide by 2.
Yeah, I just said that bit.
And I have a divided by 2 bit.
Okay, look. Yeah?
Half.
Okay.
Teamwork.
Alright.
Oh.
Alright.
Current.
5k, actually 5k, I don't need that. 5k, this is nums, right? Okay. K equals, actually this meter is k, yeah? K equals what?
K.
F mid,
Middle.
right? Yeah?
F
Tell me.
mid. F mid.
Okay,
If K equals middle.
if k equals middle,
Yeah.
we found it, right? We found the answer, yeah? Return k, right? Yeah? This is the number we're looking for, right? Then if this k is smaller than,
Middle.
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 is smaller than middle, k is smaller than middle, what do we do? And then
Right.
s, what do we do?
Right equals middle
If-
minus
if-
1.
If
Left-
k is smaller than middle,
Right minus minus 1.
Else
Left
equals
equals middle plus 1.
And return if here, you return what?
Minus 1.
Okay, so can you explain to me why is this? If k is smaller than middle, so if they are less number than mid, which is smaller or equal than the mid number, we need to reduce the number of k, right? So it will make it bigger. It will be more, right? Am I right? Can you? This is a bit tricky to understand. Look, Eric. If the mid equals k, great, we found it. But if k is smaller than the middle, what does it mean? What does it mean, Eric? K is here. K is here. If they are k numbers which are bigger or equal than k, which is smaller than expected, right? Which is smaller than expected. So we want to, if k is smaller than the expected, k is the answer. If there are number of numbers which are smaller, k is smaller than expected. So what do? We need to reduce the mid, right? We need to search in the lower half here, right? So the k will be bigger, right? Alright? Got it? If k is bigger, on the other hand, if k is bigger, we want to increase that. We want to search in this bit. So the next time k will be smaller, right? Got it? And we can finally search this bit. So this algorithm will be O log max nums, yeah? And times here, this function is O. What's this? What's this? Log n, this function. Log n. Okay, O log max n, log n. What's the space complexity?
1.
Oh, 1, yes, well done. Okay, just this bit, easy to understand. What's here? How do you calculate the middle?
Middle.
Yeah. Yeah, middle.
It's been 27 minutes.
Yes. Thank you for counting. I already know that.
I didn't know that without looking. Let me see the answer.
Yeah.
27. Yeah.
Left what? How do you calculate the middle from the left and right?
Add right.
And then?
Divided by 2.
But you need to bracket, right? Otherwise, these will calculate first. Left plus right, bracket. Do you understand? Yeah?
Whatever you say.
Yeah, does it make sense?
Bye.
Okay, bye-bye. Bye-bye.
Bye-bye.
Bye-bye.
Bye.